Radiation damage and recovery mechanisms of various scintillators and fibers. In the introduction and discussion, we talk about how scintillators and optical fibers are used in particle experiments to measure the energies and tracks of particles. The intensity of the light is proportional to the energy deposited of the particle, which is proportional to its momentum and other properties. So it's important to understand how much light is being deposited. As a scintillator is exposed to radiation, the light it produces is degraded. The scintillation intensity goes down, the optical clarity of the scintillators goes down, so the tiles just get darker in both ways. So what we wanted to investigate was this process of radiation damage, and then is it possible to recover a tile either naturally or with some aids? And so in this first panel titled RADAM Studies, we took polyethylene naphthalate and polyethylene terephthalate, which are some common plastics, which are also scintillators. So they are cheap, easy to obtain, and they have similar properties to other scintillators. We exposed them to gamma radiation from a cesium-137 source, that's 6,000 curies. And we exposed them to a low dose, 1.4 megarads, and a high dose, 14 megarad, which are, actually both high doses, but at CERN, for example, this is a common radiation exposure. And what we found is that after we irradiated them, they do recover. The amount of light goes back to an initial amount. You can see the recovery yield hitting a plateau, so they do recover. There is a time component. We published this response. Then we looked at whether we could improve this, the time it takes to recover and the robustness of the recovery. And we found that if we used LEDs, if we radiated the tile and we kept one in a dark box and we kept another equivalent tile in an apparatus that had LEDs, and we exposed them to LED light, and what I did is program it to blink and just pulse on, pulse off, pulse on at a regular interval like that, and we found that the recovery was significantly faster and more robust. So it recovered to a higher amount, and it got there more quickly. So we're currently investigating this relationship right now further to understand if there's, a certain color that works better than others. Is there a relationship between the absorption and emission spectra of the scintillator and the RGB or the color LED used? So we're investigating that right now. And then what we wanted to discover and observe in the third panel is the radiation damage in real time. So we took scintillators, we put quartz fibers through them, we pulsed light in and out, and we measured the light before and after it went through the tile using a dual spectrometer. And what you can see here is that we compared the signal out to the signal in, and you can see that the transmission's going down. And in particular, in the 450, 500 nanometer area, the blue light gets damaged very quickly, right away, goes down immediately. And then the other interesting thing is that the damage happens very quickly. So you can see that the lines get closer together at the bottom, so that it reaches sort of a maximum damage and then doesn't really get more damage than that. And then what we found is that we could let these, in this case, these were optical fibers, scintillating fibers. What we found is that if we let them recover naturally and then re-irradiated them, that the initial recovery, the damage after recovery happened more quickly than the initial damage from an original brand new scintillator. So even though the recovery happens more quickly, with light being pulsed through the fibers, the damage is happens quickly after that. So you might design an experiment to use a scintillator, and you would say, okay, well, when we turn it off, it's going to recover. So then when we turn it back on, we'll have this much time before it gets damaged again. But that's actually what we found, is that damage happens a lot more quickly after an initial radiation recovery thing. And a lot of people don't study that. So let me know if you have any questions.